Let's convert some rectangular equations into polar form. Remember, whenever we're doing these conversions back and forth between rectangular and polar, we have to make sure that we use these relationships that I wrote in the bottom right. R squared equals x squared plus y squared, Pythagorean theorem. X equals r cosine theta, y equals r sine theta, and theta equals tangent inverse of y over x. We want to be able to replace, so whenever you see a y, you're plugging in r sine theta. Whenever you see an x, you plug in r cosine theta. That's always what I try to do first when I'm looking at rectangular equations and trying to change them into polar. So looking at this first one, well, y, I know that's r sine theta. And 2x squared, that kind of stumps some people, but let's just get rid of the x. R cosine theta squared. Making sure that we distribute this square to both terms in there. So we've got r sine of theta equals 2r squared cosine squared theta. Technically, everything's in polar now. We got rid of the x and the y's, but we can clean this up, make it look way better. Let's get r by itself. First things first, we got an r squared on one side, r on the other. This is something that feels super illegal, but I promise it's okay. We're going to divide both sides by r. Get rid of it. Then we're just left with sine theta equals 2r cosine squared. I want to solve for r, so we'll divide both sides by 2 cosine squared. I'm going to put r on the left because I like that better. So r equals sine theta divided by 2 cosine squared theta. Ta-da! Except no, because we don't like it when trig functions are in the denominator. So let's simplify this a little bit more. We're almost done. This is the best part, honestly. Let's split this up into 1/2 times sine of theta over cosine theta times 1 over cosine theta. Right, all I'm doing is splitting up that denominator, making sure when we multiply all these back together, we get the original. But now we can rewrite it. Sine over cosine, well, that's just equal to tangent. 1 over cosine, that's secant. And then don't forget about the 1/2. Now we're done. So fun. Let's try another. X minus 3 squared plus y squared equals 9. Remember how in the last one I said, every time you see an x, plug in r cosine theta. Every time you see a y, plug in r sine theta. If you see parentheses, you're going to pause, and first you're going to distribute because maybe another opportunity presents itself. So let's go ahead and FOIL out this binomial squared. X minus 3 squared becomes x squared minus 6x plus 9. Then we have that plus y squared equals 9. I'm going to move this around. I'm going to put the 6x and the 9 and move those over to the other side. And you'll see why in a second. I add 6x and I subtract 9 from both sides. And we get x squared plus y squared equals 6x. Ta-da! This is looking better. Now we could try to wholesale do r cosine theta for x and r sine of theta for y. But why do that when I can just replace x squared plus y squared with r squared? Right now I've got an x all by itself, so that one I'm going to replace with r cosine theta. And we're almost done. Since I've got an r on one side, r squared on the other, let's divide both sides by r. That is totally okay. And we're left with r equals 6 cosine theta.